Hello, my name is Shay Curry, and here is my video on modeling critical thinking. So my field of study is elementary education, so this presentation is modeled after a third grade math lesson on solving for area and perimeter. So my students need assistance with using their critical thinking skills to solve for area and perimeter, so I'm going to use one strategy called the Think Aloud strategy to model different branching options for my students to use in order to solve for area and perimeter. So based on the topic that I chose, the assumptions that I came up with are 1. That students get confused between area and perimeter. 2. That students are not confident in their ability to multiply, so they would rather count the squares. 3. Students want to take the easy route and count the squares, rather than use multiplication or addition to solve the problems. So going back to the first assumption, students get confused between area and perimeter. What I think I can do to fix this is to provide students with color-coded visuals, like the two that are shown here. So this one is area. I have shaded the whole inside with red to show that area is inside. I also labeled this side 5 centimeters times 3 centimeters, and then wrote down here why I did that. Length times width is what we use to find the area. So then I wrote 5 times 3. And then going over to perimeter, I did the same thing. So I labeled perimeter in blue, and then outlined the perimeter in blue as well. And then did the same kind of thing where I focus on the 5. And instead of multiplication, we're going to use addition, plus the 3, plus another 5, and then plus another 3. So I wrote why we do that. We add all of the sides, and then I wrote it out here. So I think that doing that using the visual aids will help students with their confusion between area and perimeter. So going to the second assumption, students are not confident in their ability to multiply, so they would rather count the squares. So this is assuming that my students are not confident with multiplication, so they would rather use the easier route and count the squares. So to address this, I do allow my students to use their multiplication charts to help them with multiplication, because I know that it can be very difficult if they're not confident in their abilities to multiply to use multiplication in practice. So I do allow them to use the charts. They have these on their desks, and they are allowed to use them when we do these activities. So the third assumption is a little bit similar to the second, but this one says that students want to take the easy route and count the squares rather than use multiplication or addition to solve the problems. So the second assumption assumes that they are not confident in their abilities to multiply, and this assumption assumes that students maybe know how to add and multiply, but they determined that it usually is a little easier just to count the squares. So this assumption is assuming that they're just taking the easiest route to find the answer. So I do allow students to count squares if they have no other way of solving the problem. So if they can't come up with a solution to the problem, I do allow them to count the squares. I don't want to see this in every problem, but I do allow it. But I do encourage students to use their resources, such as their multiplication chart, and to only use the counting method as their last resort, or to check answers. So, for example, if they were just going to solve this problem for area using multiplication, 5 times 3, they would come up with 15 for the area, and then for the perimeter, they would add the sides 5 plus 3 plus 5 plus 3 to get 16. So when they count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, they would come up with the area. So they can double check by counting to check that the area is actually 15, which they would have gotten from 5 times 3. So the strategy that I'm using to model critical thinking to my students is called the Think Aloud strategy. So here I'm going to introduce a little bit about the Think Aloud strategy before moving on to my branching options to show different ways that students may use their critical thinking to solve problems. So the Think Aloud strategy is a little bit different than a model, and it goes above and beyond what a model does. Modeling is simply showing someone how to do something with no further explanation of how or why to do it that way. Modeling does not really have a strong impact on students' thinking or their ability to execute the activity. A Think Aloud takes a simple modeling strategy and improves it with explanation and commentary. So for branching option number 1, we have counting squares. So that's the strategy that we're going to use to solve for area and perimeter. So in a regular model, I might tell my students, I counted the squares, the area is 15. I counted the squares a different way, and the perimeter was 16. But that doesn't really tell my students how I got it or how they can solve it on their own. In a Think Aloud strategy, I would walk my students through every step of the process, and I would explain it as I'm walking them through. And this is a more practical way of explaining things to students because it allows them to listen to every step of your thought process and actually use this to apply it to their own thinking in the future. So when I walk my students through something, they should, in theory, then be able to do it on their own after I've walked them through it because they've heard every step of the process and now they can apply every step of the process. So for this one, if we're solving for the area, which we know is 5 times 3, we also know that the area is the inside, so we could count all of the squares in the inside. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we can double check our work by using the formula 5 times 3, and we would get 15. The area is the inside. This is why we counted all of the squares once inside the rectangle as a whole. And then if we wanted to count for perimeter, we know that the perimeter is the outside. So we could count all of the lines on the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we can double check this, and we should have an answer of 16. It would be 5 plus 3 is 8, plus 5 plus 3 is 16. So we know that that is correct. So this is how we would use the Think Aloud strategy to walk students through it. So we are counting each of these outside lines, and even though we're counting, this is one square, we're counting these lines twice, is because we're counting the outside. So even though it's one square, and they might share a corner here, we're still going to count each one as one, so that we can get the total for the entire perimeter. So for branching option 2, we have addition. So to find the area and perimeter using addition, we first need to understand what they are, which is what the visuals were for. So the students know that the perimeter is the outside and the area is the inside. So to find perimeter using addition is very easy because we're going to add each of the sides. So the first step is to label the sides. So if this side is 5, we can use our previous method of counting the squares to determine the other side. 1, 2, 3, 4, 5. So then we would label this side with a 5. And then 1, 2, 3. So we know that this side is a 3. And then we know that perimeter as I showed on the previous slide, the formula is to add all of the sides. So we would add 5 plus 3 plus 5 plus 3. And then once we add all those, we would get 16, which we could then check with the method we just used of counting squares. So for area, we know that the formula is length times width. But again, if we're not comfortable with using multiplication, we could always break this problem down into 5 plus 5 plus 5. So we know that the formula for area is length times width, as shown before. So it would be this side times this side. But we are just using this problem to simplify it in our brains if we can't do 5 times 3 mentally. So this means 5 3 times. So we have 1 5, 2 5, 3 5s. And then once we add that, we are going to get 15. And if we double check that using our counting methods, we would get the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is how I would explain the process of using addition using the Think Aloud strategy model. So the third branching option is our last one, and it's going to be focusing on multiplication. So we're going to use multiplication to solve for area and perimeter. So I'm going to explain this strategy to my students using the Think Aloud strategy, and I'm going to show them how we can use multiplication to solve for area, which is going to be a little bit easier because that calls for multiplication in the formula. And then I'm also going to show them how to incorporate multiplication into the perimeter as well, just in case students find that a little bit easier to use, because the whole idea of branching options is that students have different thought processes. So some thought processes work differently for each different student. So I'm going to incorporate multiplication into area and perimeter using the Think Aloud strategy. So let's turn that to red. So to find the area, we know that the formula is length times width because we've looked at that before. So it's going to be this times this. So pretty simple. We know that this side is 5 and this side is 3 because it's already labeled for us. But if it wasn't labeled for us, we could always use our counting strategy and count all the lines along the outside. So we'd get 1, 2, 3, 4, 5. Then we could fill this in ourselves if we didn't have it there. So we would label this 5, and then 1, 2, 3, and then we can come up with the 3 ourselves again, if we didn't have it there already. So we would get 5, and then we know that area uses multiplication, so I would fill in that little times there, and then fill in our 3 for the other side length. So for our area, we would get 5 times 3. If you can do that in your head, great. If you can't, you may use your multiplication chart. So we're going to do it together. 5, 10, 15. So we should be able to count by 5s. But like I said, if you forgot or if you couldn't do it, you can always use your multiplication chart. So for perimeter, we know that this formula does not use multiplication. This perimeter looks at the whole outside of the rectangle, and it calls for us to add up all of the sides. So we're going to be using addition. So we're going to look at the 5 here, the 3 here, and these sides are not labeled for us, so we're going to fill those in ourselves. Let's use our counting method. 1, 2, 3, 4, 5. So we know that our side length here is a 5, and then 1, 2, 3. So we have a 3 on this side. So our formula would look like this. 5 plus 3, or 5 plus 5 plus 3 plus 3. We'll keep the like numbers next to each other so that we can use our multiplication method. If we think that addition is going to take us a little bit longer to solve, we can simplify this by looking here. So we have 2 5s, 1, 2, so that means that's the same as 2 times 5. And then we can add this to 3 times 2. And the reason that this strategy might be a little bit quicker for us is because a lot of us know in our heads that 2 times 5 is 10, and 3 times 2 is 6. So some of us might have even been able to do this multiplication in our heads by ourselves. So 10 plus 6 is 16, and we can confirm this using our counting method. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And just like before, we've come to 16 as our perimeter using multiplication instead of addition. Thank you, and here are my references.